Hi, everyone. My name is Adriana, and I am part of the DevRel team within Elastic. I'm here to introduce my colleague Ashish in a bit, who will start with an introduction, and then after that, Sonam and Akshay will give their talk. At the end, we will have a Q&A, so feel free to leave all your questions in the YouTube comments, and we will do our best to answer as many as we can. If you have any Elastic related questions, you can find us on YouTube, on Discuss, and on Slack. So feel free to find us there. And if you are interested in presenting at a future meetup, whether that is in person or virtual, you can email us at meetups@elastic.co. So feel free to reach out anytime. And if you would like to join a future meetup close by where you live, you can scan the QR code or go to meetup.com/pro/elastic and find a user group that's close by you. We have many all over the world. And now I'm going to introduce my colleague Ashish to the stage, and he can take it from there. Hi, Ashish. Good to
Hey,
have you here.
Adrian. Thanks for pulling me. And hello, everyone. Good morning, good afternoon, good evening, and welcome to today's meetup. I think today's meetup is very special because we are going to discuss a lot of things about the vector space. Might be how you are generating embeddings, mostly focusing on the EmbedAnything library. If you want to embed your text, your image, your audio, I think this is the meetup for you. So and after that, how you can generate the embeddings and you push to elastic cloud or elastic search, and on the top of it you can perform the semantic search, whether you want to perform an image search, audio search, or semantic text search. Everything is possible. So before jumping on that, let's quickly have a go through on our what's new in Elastic. And if you are aware, we recently launched the Elastic 8.16. I think this blog you can follow, but I'll quickly skim through it. So in 8.16, our major highlight is we have introduced the better binary quantization. So in fact, the Elasticsearch is the first vector database which where we have introduced the BBQ. And what does mean is, when you usually generating the embeddings, it's a lot. It's a lot, definitely, and you're pushing into vector database like Elasticsearch, and it start taking your space, right? With the help of the quantization, you can reduce your spaces for the vectors. So better binary quantization is one of the technique. Though Elastic has released a multiple way to quantize it, like a bit quantization, byte quantization, and int 8 quantization, like that. But this is one of the finest quantization you can ever see. So as we benchmark, you will get the 32x. You can reduce your space with the 32x with the help of the better binary quantizations. So please go and check how it looks like. We got a very good blog available, all the mathematical explanation, how we are doing, what techniques we are using to comprise it. So please go through it and just play around it, right? Apart from this, we got a very good releases around the observability and the security. So an observability, if you are a fan of open telemetry, and definitely if you are looking for the vendor neutral observability specs, so you can try it out open telemetry. And we got e dot, like elastic distribution of open telemetry. So we got a e dot SDKs, and we got a e dot collector. And in this release, if you want to try auto instrument or auto monitoring on the Kubernetes with the help of the open telemetry, you can just follow this release note, and there is a wonderful blog available, which where you can just go. It will automatically deploy the e dot SDKs and e dot collector, and your Kubernetes dashboard is ready without touching your code. So feel free to utilize it and just play, and happy to have a feedback. Apart from this, we got search AI assistants as well. We have improved our Elasticsearch query language. We have start giving the query recommendations. So if you are start utilizing ESQL, as you start typing the query, it will start giving the suggestions. Apart from this, I think if you recall, we got a semantic underscore text capability, which help you to chunk your data on fly. Earlier, it was a fix with the 250 words and 100 words overlapping, but now it is purely configurable. So you can configure according to your use cases. So feel free to go and check the 8.16 release notes here, and where you will get the each and every details how we are doing into Elasticsearch, observability, security, and search spaces. And without taking more time, I think let me call Sonam from the EmbedAnything team. I think she is a co-creator basically, and I think let me pull the Sonam at Sonam. Let me add to stage. So Sonam is a co-creator EmbedAnything, and recently I contributed to the EmbedAnything as a adapter, as an Elasticsearch adapter. So the team is doing a fantastic job, definitely. And if you are looking for creating embeddings from your text, image, audio, right, and it's more efficient way, right? So EmbedAnything is a go-to library. I think we got a wonderful team, Sonam and Akshay will join after some time. But Sonam will continue from here. So Sonam, over to you. And yeah.
Thank you, Ashish. Let me share my screen. So hi everyone, I'm Sonam from EmbedAnything. I'm also working at Articulate as GenerativeAI Evangelist. I'm joined by Akshay Ballal, who is also the co-creator of EmbedAnything and is working at ASML. Today we are going to talk about memory efficient indexing, especially with Elastic Cloud. First of all, let's discuss vectors. Like vectors are the numerical representation of these images, documents, you have audios, and where they are used. They're used in training large language models. They are used in search, especially RAG is like exploded, and now recommendation systems. So what's EmbedAnything? It's Rust Power framework for your end-to-end from source, any unstructured source, images, PDFs, audios, to your vector database. We have gotten 80,000 downloads in this 5 months, and we are shooting for 300 stars. But most of you understand EmbedAnything as the generation part, but there are actually three parts working coherently together. There is ingestion pipeline, there's ingestion part, there's inference part, and then there's indexing part. Ingestion takes care of all the pre-processing of your documents, be it extraction of text, be it metadata extraction. Inference part, which is the major part of EmbedAnything, takes care of inferencing both on Candle and on ONNX. Why Candle will be very well explained by my colleague Akshay Ballal. A lot of memory footprint is reduced. I could just give you an overview. It reduces a memory footprint a lot. It is much faster. It is specifically made for transformer-based embedding models. We support dense, sparse, cold pally, clip, whisper, etc. And the major part that we will discuss today was in the indexing part, and we built this vector string method that will be explained. So all these three parts are written in Rust from the ground up. So you will not find any spaghetti code. You will not find running any random things, random sentence transformer anywhere. Everything is written from the ground up in Rust. So what were the problems that were existing? Slow is one of that, high memory footprint. Most of them uses libtorch, pytorch, many dependencies. So these library that used to exist were very good for POC, but it's a hell to take it into production. Most of them are cloud-based, no metadata extraction, and no pre-processing. Okay, so how does EmbedAnything handles everything? It's a highly performant, it's a very fast, plus most of the embeddings are quite accurate. Minimalistic, we have reduced dependencies on anything that is not relevant to us, even torch. We have even removed torch, lightweight. It's extremely lightweight because we use candle, we do not need torch. Multi-source, we ingest multi-source, we ingest documents, we ingest images, we ingest audios. Multimodal, again, different modalities are supported, lightning fast. The models we support, again, dense, we support BERT, GINA, sparse, any kind of sparse model. Colpali, interesting thing is Colpali ONX is also supported. Clip and Whisper. Now, existing solutions were sentence transformers, fast embed, and the Olama. So we had a lot of comparison with fast embed, but I just want to tell you that we also take care of ingestion quite well. We take care of all the metadata extraction. We take care of pre-processing as well. So here is a kind of a table that kind summarize it for you what extras EmbedAnything provides. So yes, multiple embedding models, inference on ONX, image embedding are present in all the three. Sparse embedding and late interaction are only present in EmbedAnything and fast embed. Cold Pali models are only presented by EmbedAnything. Pre-processing, meta-extraction, inference are taken care of by EmbedAnything, but not by fast embed and sentence transformer. And then fine-tuning. So fine-tuning currently you can do only with sentence transformer, but we are going to bring it in EmbedAnything as well in the future. So performance. We have okay, so this is quite lenient. Like we have only measured the embedding model inference speed. We haven't taken care of ingestion pipeline as well. So if you start including ingestion, it will like kind of the gradient increases. That is, EmbedAnything becomes much faster. This is based on ONX runtime only, and this to simulate a high number of documents. We have repeated this experiment hundreds of times on the street, and these are present on our benches collab. So now to take over from Candle Framework, I invite my colleague Akshay Ballal to present Candle Framework and what it provides to EmbedAnything.
Hey, hi everyone. Thanks Sonam for the great introduction to EmbedAnything. So now I want to get into the main highlight of this talk, which is vector streaming. So yeah, just to confirm, my screen is visible. Yeah, all right. Yeah, so Sonam did mention candle a few times in this talk. So just want to because this is kind of new and it is growing. So I want to just share what candle is about because this is kind of like the heart of EmbedAnything. So it's an ML framework that's developed by Hugging Face and it's been in development for the last couple of years, but it has picked up steam recently a lot with a lot of models being added. So it is completely built in Rust as well from scratch. So it is very performant. It has a very low footprint because Torch has been growing a lot over the years. There's a lot of legacy code in it, so you get like a 1.5 GB of binary that Torch alone brings in, especially with GPU. So that's where Candle brings in the latest best practices, takes care of the hardware acceleration, and gives you a very fast library. And because of all this, it's very easy to deploy on the cloud. It's easy to create nodes of uh, code that is using Candle because there are very few dependencies, and also because it's in Rust, you can use WebAssembly to have native browser compute support. So within the browser itself, you can use the local resources from the computer to do the embeddings or run large language models. So it's not just for embeddings, it's also for large language models. We use it mainly for embeddings. So And then now getting into what is the document pre-processing side of things that we're doing. So because we do ingestion as well, so what we are doing in ingestion, especially with respect to text documents, is we are doing the chunking before starting the embedding process. So you just feed in the PDF and break it down into pages, break it down into smaller chunks. You can give the chunk parameters like what's the overlap, what is the size of the chunk. And also what we have implemented is semantic chunking, which is kind of a Rust implementation of Aurelio Labs implementation that they have made. So this kind of looks at all the chunks that are there and merges chunks if they're very close to each other. So you get a more coherent representation of a single chunk, and it's so you don't drift into different topics within a chunk itself. And then we do some text cleaning, like removing white spaces, removing bad characters, and those kind of things. Those are taken care by the libraries ingestion part. And we also extract metadata, like if you are embedding a certain file, uh, you can ask it to like get metadata, like when was the file created, what is the size of the file, how many pages are there in the file. So this could be useful for when you're doing RAG and you want to show sources or those things. This can be helpful to get things from this metadata. So you don't have to worry about doing this metadata extraction manually. And one major thing is in the ingestion we support OCR. So currently we support Tesseract OCR. So if you have a scan document with text, so you cannot directly do the chunking because you need text. So first OCR model is run to extract this text, and then we can do the chunking. So this is again you just say that you want to do OCR on a PDF, and this is all taken care of for you. So what is vector streaming now? So as you saw, like there are a lot of things that are happening in the pipeline. So we are doing chunking and we are doing the embedding. So this could cause a lot of memory usage in your system, because let's say you have like hundreds of documents which are very big, or let's say videos or images or audio which are very large. You don't want to load them all into your system at once. And because one, you have a big embedding model running locally, so that is already taking up some system resources. And then when you start bringing in the files and all the activations that happen and the output as well, and if you keep all of this on the memory at once, it's you need to have a lot of memory. So what we are doing is we are streamlining this. And so the main part of vector streaming is to reduce this memory usage so that you have a constant flow of data through the whole system and not at all at once. So this also reduces the time to first output. So because you don't have to wait for everything to finish to get your first output, you can start getting an output very soon into your cloud system. So you can start showing some results already. And yeah, this has an integrated DB. So we are basically using DB as a system memory for at least storing the output, so that these outputs are not stored on your system. This is especially useful when you have large amount of files or images that you need to embed. So you can make do with a smaller resource system. So how does it all work under the hood? So we have the PDF that comes in. Which is then done. Here we make use of Rust multi-thread system, where the PDF is parallelly processed. So the preprocessor includes the OCR part, it includes the chunking part, the semantic chunking part. So it's all parallelly processed page by page. So each page is parallelly processed, and they all release their own chunks. And these chunks already include the metadata which the processor has embedded into the chunk. And this queue is created. So this is a long queue that happens, and out of this you can choose how many of them you want to send to the embedding model. So we can specify a buffer size. So let's say a buffer size of 100. So 100 of these chunks are then pushed to the embedding model, which runs on a separate process. So it's not on the main process where your code runs. So it's almost like a microservice that runs but locally. So it's not like it's using gRPC or something. So we use something called MPSC channels, which I'll show you later, to talk to this embedding model. And then when the embedding model has done processing or embedding a certain number of chunks, that output is then pushed to Elastic, and new chunks can keep coming, and this whole flow keeps happening. So at a time you only have limited number of chunks and your embedding outputs in the memory, and rest of the things are then pushed to Elastic. So this is a more specific diagram of how the architecture, how it works under the hood. So we have the main process which is doing all the processing part and the chunking and the pushing to the database. So these chunks are then using an MPSC channel. So that is multi-producer single consumer channel, which is inbuilt in Rust. So it's part of its standard library. So this then are communicated to the embedding process, where it takes in these chunks along with the metadata and everything, and produces the embeddings, which again along with all the extra payload back to the main process, which then pushes it using an adapter. So there's an adapter connecting the main process to the Elastic DB, which then which is consumed by the Elastic DB. But you don't have to worry about all this when you're actually running the code. So what we have done is, since this is written in Rust, but most of the developers use Python, we have used Pyo3 to kind of create bindings from this Rust to Python code. So all of this is done in a simple Python code. Using just a few lines of code, you can give an adapter. But here we say there's an Elasticsearch adapter. So we can specify different adapters. So we can look at what is there in an adapter. So basically, adapter is a simple wrapper around the actual vector DB's API. So basically, anything to create an index over here. So you can specify the API key, the cloud IDs. Then you need something to convert from the metadata that EmbedAnything generates to something that is a payload to the vector DB. So that conversion happens over here. And finally, a simple upsert function to take that data and push it to the database. So with a few lines of code, you can specify this adapter. So, and all of them together, then you can just with a single line of code, you can just specify this is your adapter, and whenever it embeds anything, it will keep pushing it to the database. So this is a simple result of what you will see. I'll just show you a demo in a second of how this all works. But simple plug over here of like where we use EmbedAnything. So over a few months, we have been developing Starlight Search, which is basically a local semantic search engine that we are developing to like browse through your files and search through your files. So this is a simple demo of how this works. So during the development of this, we found like there are a lot of problems with existing solutions, and this is where this inspired us to make EmbedAnything. So, and in the future, we want to implement a lot of more things. So we have got a lot of requests to implement graph embedding. So basically taking a graph and embedding it. So that is something we want to work on. Video embedding is in works right now because a lot of new models are supporting video embeddings as well. So that is something we are looking forward to put in. And another model, a mixture of models, sort of YOLO and Clip, is something I've been working on. I also released a blog recently of how you can use object detection to improve Clip. So that is something we want to bring into EmbedAnything as well, and then some more model integrations and expand the type of data sources that we support. Yeah, we'll quickly get into the demo. Just a second. Yeah, so this is a simple demo just to demonstrate like how easy it is to use EmbedAnything to start vector streaming. So we just start with some dependencies that are there. So you can use EmbedAnything GPU. So this leverages the GPU instance that is over here, which is T4, and you just need to install the Elasticsearch package. Here we just clone our EmbedAnything library. So you can see over here. Yeah, it doesn't. Yeah, so EmbedAnything library is just cloned. So just to get some files that we'll be using for this demo. Then this is the adapter that I talked about, a simple wrapper around the Elasticsearch. So it uses all your Elasticsearch functions, but in a specified wrapper. So you have this different functions that are there in that. and then we specify the index name, so we call it anything. We create the adapters where we give the API key, the cloud ID, those things. So here I'm just deleting any existing instance that might be there. Then we specify the type of embedding, so depending on the model. So here we are using the Gina base model, so which has a 768 dimension of embedding. So we just specify that and we call it a dense vector. This could be a sparse vector as well. You can specify a sparse model over here, and you can also give something called so here we can also specify a buffer size, which is by default 100. So we can also give a buffer size of 200. So it basically takes the 200 embeddings and then pushes it to the vector db. And yeah, so you can embed a directory directly and specify the model and the configuration and then give the adapter, and when you run this, basically uh, this should be pushed to the cloud. So you can see the GPU is being used by the model over here. Yeah, so it's pushed to the cloud now. And then we can just to test it out, we can do a simple query of, let's ask what are SSM models. So I have three papers over there. One is an attention.pdf, one is a SSM's paper, so that is state space models. So let's see if it can pull the state space model paper, which is called linear.pdf. Yeah, so it has pulled that paper, so you can see the metadata was already there. So here I have just specified that I need the file name modified and created, and you can use this basically to do RAG. We can also do audio files in the same vector database in the same thing. We here for audio we specify a audio decoder model, and along with our embedding model we just specify. So it first decodes it, creates the text, and then embeds it. So you can see over here that we just modify the metadata a bit to support because we didn't have modified and created, so we just keep it empty. Yeah, and then we are, so that is a basically audio talking about screwdrivers and Phillips screwdrivers and those things. So you can ask it what is the importance of screw design, and this is in the same database. So basically I took audio and put it in the same index, and also the text was put in the same index. So you can combine these different modalities and embed. So yeah, so that's the demo for EmbedAnything. I hope this is helpful, and please star our repository. We're looking forward to implement a lot of more features.
So thanks, Akshay, for the wonderful presentations, and Sonam as well. Uh, Let me pull Sonam as well. I'm in just, yep. So I think it's great to see this, and I'm super excited for what you've seen. You know, the future roadmap. I can't see any question as of now, but I do have a question. If I can just what so there is a different way of chunking, right? As you said, the semantic chunking is one of that, but there is a fixed characters length on all those stuff.
Yeah.
What kind of, I mean, is there in any how what is the what kind of the support we have, chunking support methods
Yeah,
available?
so by default, if we have by default, if you don't specify a semantic encoder,
Hmm.
uh, so then it uses a fixed length. So you can specify what is the chunk size, what is the overlap you want to have. So it's basically just a character-based chunking that happens over there.
Hmm.
Just looks at full stops and then if any semantics in terms of line change is happening, and then tries to
Yep.
incorporate that in the chunk. But
Yep.
in that, then you have a lot of hyperparameters, like what should be the size of my chunk. You don't know that.
Yes.
You don't know the overlap. You don't know where the topics change. Maybe a topic suddenly changes within a line. So that's where the semantic chunking part
Yep.
comes in. So there are three ways to implement, and one of the best ways is what we are using. That is basically a statistical semantic chunking, so which looks at the statistics of the chunks that are created. So we try to keep every chunk as equal as possible, the length of a chunk. Also try to keep as much context in a chunk as possible. So
Mhm.
the idea is that you break down into like very small
Yeah.
chunks and use an encoder to first create the similarities between them, and if they are similar, mix them together, and you mix
Got
them
it.
such that they are, you don't get like a very small chunk somewhere. So that is the statistical part of it. Yeah,
Got it. Got it. I think, yeah. Because I think chunking is plays important role into the RAG, and if you're not doing performing chunking better, I think your end result is going to always
that's
going to
right.
impact.
Yeah.
Great. I think it's super memory efficient library, as I can see. So, is there a parameter I can configure my memory as well? I mean, if I have a low hardware, or
Yeah, so
if
the
I have,
buffer size is something that you can play with. So let's say
okay.
you don't you have a low, so basically then you can keep your buffer size low to, let's say, just 10 embeddings that are processed at a time. So that also reduces the load on the embedding model,
Mm-hmm.
because embedding model then doesn't has to have to parallelly process a lot of things. So so there also, because you have less activations, your memory footprint goes down, and also you have less number of outputs that come out, so and also less number of inputs. So overall everything goes down if you reduce the buffer size.
Yeah.
So
Yeah.
that is something you can play with depending on your system resources.
Mhm. So, if you done, I mean, definitely you must have done testing. What is the, I mean, what is the ideal, if I say the good number of, I have to set a buffer for the embedding
Yeah,
library?
so it depends on a few things, but we found like 100 to 200 is something good enough at
Wow.
least, but it does depend on the hardware. So if you have a good hardware, let's say a very good GPU, you can
Mm-hmm.
just crank it up a lot, because then you have a lot of VRAM. You have
Mm.
almost like 30 GB of VRAM on the
Yeah.
latest graphic cards. So
Mm-hmm.
in that case, it doesn't really matter. Like you just keep it as high as possible until you like hit some ceiling. So
Got
just
it.
look for that ceiling. But sometimes if you have very small documents also, it's a problem, because then you have basically some basically extra resources that are used to parallelize things. So if you have very less then it doesn't matter that you keep higher buffers, then you can just load it all at once. Yeah.
All right, all right. And is there any way to control the threading as well? I mean, if I have a good course available,
Mhm.
and I can.
So right now it just uses everything that you have. So it
All right.
yeah.
So
But that
it's
is
take a
something we can
default.
look into, where you
Yeah.
can like choose how much you want to. But right now it just
Mm-hmm.
looks for the maximum number of cores that you have, and does because that is a CPU task.
Yeah.
So the cores so the chunking is basically your CPU task.
Yes.
That part of it, because OCR
Mm-hmm.
model runs on CPU. So that's
Yeah.
where this comes in, where we can configure how many threads parallelized. But the
Mm-hmm.
embedding model as such, if you are using it on GPU, then it's not a CPU part. So there it anyway uses everything that the GPU has to offer. Yeah.
All right, all right. Great. Then I guess there is a no other question. But if you got any question, feel free to comment on our the YouTube this video, and feel free to reach out to EmbedAnything team. They are doing something cool stuff these days. And if you have any doubt around the Gen AI, vector DBs, and Elastic, just feel free to reach out to me, or the other Elastic members. So with that, I think we are good. Thanks for joining us, and have a great day. And soon we going to arrange more such great virtual meetups and around the Gen A and stuff. So thank you very much. Have a great day. Bye.
Yeah.